Okay, this is Module 4, Lesson 13. Still talking about populations and samples. And here we're talking about the population characteristics and the sample statistics. Excuse me. It says, a statistical study begins with a question of interest that can be answered by data. Depending on the study, data could be collected from all individuals in the population or from a random sample of individuals selected from the population. Read through the following and identify which of the summary measures represents a population characteristic and which represents a sample statistic. Explain your reasoning for each. Okay. Don't be confused by characteristic or statistics. That does not matter. If it comes from a population, then it is a population characteristic. If it comes from a sample, it is a sample statistic. Okay, that's the easiest way to remember that. So, what is an actual population characteristic? Well, that's a summary calculated using all the individuals in the population. Okay. So, a population proportion and a population mean are two examples of population characteristics. Okay, that's just what it is, but it's all coming from a population. Now, for a sample statistic, this is a summary calculated using the data of a random sample. Okay. Now, if you have a sample proportion or a sample mean, that would be considered a sample statistic. Okay, so that's very basic, but it's just, if you're pulling from the population, it's a population characteristic. If you're pulling from the sample, it's a sample statistic. Okay, and the two things are a proportion or the mean, if you're gathering the mean. Now, so suppose the population of the interest is the words of the Gettysburg Address. There are 269 of them, once again, depending on the version. So, the proportion of nouns in all words of the Gettysburg Address. So, all the words, that's going to come from the population. So, it's a population characteristic because it's determined from all the words or the entire population. Let's look at the proportion of nouns or the proportion of words containing the letter E in a random sample. Well, there's your answer. It's a sample statistic. It's very simple. All right, let's look at the mean length of the words in a random sample. Once again, it's going to it has to tell you whether it's coming from a sample or if it's coming from a population. So if it does that, you already know your answer. This is going to come from a sample statistic because it's not the entire population. The proportion of all the words of the Gettysburg Address that contains the letter E. Well, you're looking at all the words, so it's a population characteristic because it is determined from all the words. All. All right, one more. The mean length of all words. There you go. Another population characteristic. Super simple. If it comes from a population characteristic, or if it's come from a population, it's a population characteristic. If it's come from a sample, it's a sample statistic. Page 7. Exercise 3 says, for the following items of interest, describe an appropriate population. Population characteristic, sample, and sample statistic. Explain your answer. So if you describe that it's an appropriate population, you're going to give me a characteristic. You're not going to give me a sample statistic because you're not looking at a sample. Right. It says time taken, or time it takes students to run a quarter mile. Okay, well, if you pull every student, then you would have you may pull the mean, so you'd have a population mean. But if you only take certain students, maybe the high school students, then it would only be a sample statistic. Okay? So let's see here. It says a population. All students in the 11th grade at your school. Okay, well, the mean times for a quarter mile of all the students of 11th grade at your school. Now, a sample would be a random selection of the students in 11th grade. All right, and you could find the mean time. Once again, it doesn't matter that it's a mean. It only matters whether you're pulling it from a population or from a sample. That's all it is. And if you're using every student in the 11th grade, then that's population. If you're only pulling a random number of them, It would be a sample. All right, national forests that contain bald eagle nest. Well, all the forests in the United States, and you would take the proportion of all the national forests in the United States that contains bald eagle nest. Now, instead of finding, so what happens here is, if you don't want to go through every single national forest, then you would just pull a sample of them, create a random number, assign each one of them a number, every national forest a number, do a random number generator or a random number table, pull 30 samples of those, and then you could get a random selection, and therefore you would have a sample statistic because you would have the proportion of the sample national forest in the United States that contain bald eagle nest. All right, let's look at curfew times of boys compared to girls. Well, we could have all the boys and girls in 11th grade at your school. Okay, if that's the population, and we take the mean of the boys, we subtract the mean of the girls, we would have a population characteristic of the difference in means. Now, if you only take a random selection of boys and a random sample of girls, or a selection of girls, then you would just have the difference of the mean in a sample of them. So it would be a sample statistic. I hope that's very easy. I hope that's not confusing, because it's simply that. If you're looking at the whole population, it's a population characteristic. If you're looking at a sample, you're looking at a sample statistic. Okay. Page 8 says, what about the efficiency of electric cars? Okay. Well, you're going to have to pull all electric cars currently being marketed right now, all right, or on the market right now. And you would take the mean number of kilowatts an hour to drive 100 miles for all electric cars currently being marketed. All of this doesn't really matter right here. What you're actually doing, all that matters is that you're looking at all the current cars, and you're taking a mean, which is a characteristic of the population, or therefore a population characteristic. Don't get hung up on that type of stuff, of what's it actually talking about. All right, a random sample of selection of cars currently being marketed. Say you're going to pull 2 from each brand, each manufacturer. You're not going to look at all of them. You're just going to pull the top 2, or maybe the just any 2. You have to somehow randomly select those cars, and you pull a mean, which is a statistic, and it's a sample statistic because it's being pulled from a sample of electric cars being marketed. All right, so lesson summary. We refer to summary measures calculated using data from an entire population as a population characteristic. We refer to summary measures calculated using data from a sample as a sample statistic. To generalize from a sample to the corresponding population, it is important that the sample be a random sample from the population. And it also has to be representative of the population. That way you don't have any bias. A random sample is one that's selected in a way that gives every different possible sample an equal chance of being chosen. That's what I'm talking about. You can't have any bias there.